right. So for problem 12, it states if sine of x is equal to -3/5 and x is an angle in quadrant 3, find the value of tan of x. So what you want to do here is first sketch your angle in quad 3. Okay. So the initial side of your angle, right? The vertex is going to always be the origin. The initial side of your angle is the positive x-axis, and the terminal side, I'll do the terminal side in red, should be somewhere in quad 3. So here, what I represent here in green is my theta. That's my angle. Okay. And what I have now is to figure out what this does. How does the sine of x equals -3/5 is helpful? Well, from some point on the coterminal angle here, I can draw a basically a perpendicular line, so that way I could form a right triangle. Okay. Now that I formed that right triangle, I'm just going to zoom in a little bit. I could use my sine of x equals -3/5 and a little bit of right triangle trigonometry to label at least two of the sides, right? So recall, sine of theta is always equal to opposite over the hypotenuse. So the angle of reference would be this angle, right? That would be essentially my angle there. I'll probably use a different color. I'll probably use the yellow over the green. So that's my angle of reference. So the opposite side will be located here, and this would be my hypotenuse. Okay, so we were given that sine of x is -3/5. So the opposite must be equal to -3, and the hypotenuse of that right triangle must be 5. So the opposite, again, is -3. The hypotenuse is 5. Now, based on our right triangle that I drew, what side of the right triangle is missing? The adjacent. Very good. So the missing side is the adjacent, but we can always figure out what the adjacent side is by using the Pythagorean theorem, right? So the Pythagorean theorem states opposite squared plus adjacent squared is equal to the hypotenuse squared. The opposite is -3. So you have -3 squared plus adjacent squared, which I need to find, is equal to the hypotenuse squared. The hypotenuse is 5. All right. So -3 squared is 9. 5 squared is 25. So we have adjacent squared here. So I subtract 9 on both sides. You'll get the adjacent squared is equal to 25 minus 9, which, by the way, is 16. But we don't want adjacent squared. We want the just adjacent. So I need to take the square root on both sides. When I do, the left-hand side of the equation will read as adjacent equals plus or minus the square root of 16. So there's actually two solutions here. When you're going to apply the square root property, you get two solutions. You get either plus or minus square root of 16. But by the way, square root of 16 is just 4. So it's plus or minus 4. Now, which one do you think is the right answer? Is the answer going to be +4 or -4? Careful. The answer to this problem will be -4. Why? Because your angle's in quadrant 3. Whenever your angle's in quadrant 3, both the x and y values are negative. Okay, so we are going to reject the adjacent being +4, right? The adjacent value now must be -4. Okay, so now since we have all three sides of our right triangle labeled on the Cartesian plane here, you can find tangent of x. So by the definition, tangent is always opposite over the adjacent. The opposite was -3, the adjacent was -4. You can simplify this by getting rid of the negatives, and you get 3 over 4 as the solution. Okay, so that's how you would solve problem number 12 on your final exam.